Hello everyone. In this video, we will be studying question number 7 and 8. So now here we will see question number 7. Use your method from problem 6 to check if the points R minus 5 minus 1, B minus 2 minus 5 and C 4 comma minus 12 are on the same straight line. So we have to check whether all these 3 points are on the same straight line, and then now plot both sets of points and check your answer. So we have to also plot and check once we solve this. So we have to solve this using distance formula. Okay. So using distance formula, we will check this whether all these 3 points they lie on same straight line. So what is distance formula? We will write the formula here. So the formula is x2 minus x1 whole square plus y2 minus y1 the whole. Now, now we will write all the 3 points here once again. So point R is minus 5 comma minus 1. Then B, B is minus 2 comma minus 5. And then C is 4 comma minus 2. So first what we will do now, first we will find the distance RB. Okay, so RB distance we will find, and for that what we will do is we will consider this as x1 y1 and this as x2 y2, and we will use these coordinates in this formula and we will find the distance of RB. Okay, so we will do that here. Now x2 is what? X2 is minus 2 minus x1 is what? X1 is minus 5, so again minus 5 square plus y2 is how much? Minus 5 minus from the formula y1 is how much? Minus 1, again minus 1, the whole square. Okay, now we will solve further. Minus 2 minus minus will become plus, so minus 2 minus minus is plus 5 square plus minus 5 minus minus is plus 1 square is equal to minus 2 and plus 5 is plus 3, so 3 is a square plus here it will be minus 4 the square. So 3 3s is 9, 4 4s is 16, and minus minus will become plus here, and 9 plus 16 is 25, and 25 means it is 5 5 is a 25, so 5 units. So the distance is how much? Distance is 5 units. Okay, so RB is 5 units. Now what we will do is we will find the distance of BC, and while finding the distance of BC I have taken B as x1 y1 and C as x2 y2. So now we will find distance BC using the same formula, distance formula. So x2 is 4, 4 minus x1 is again minus 2 square plus as per this formula. Now y2 is how much? Y2 is minus 12 minus from the formula, and y1 is how much? Minus 5. So minus 5, so equal to 4 minus minus is plus 4 plus 2 is square plus minus 12, and minus minus is plus 5 square is equal to 4 plus 2 is 6 square plus minus 5 minus 12 plus 5 is minus 7 square. So 6 6 are 56 and 7 7 are 49, and minus 1 is plus 50. 36 plus 49 is 85. Okay. And so 85 units. Okay. So BC is how much? BC is 85 units. Now on the next page we will find the distance RC, and while doing that we will take R as x1 y1 and C as x2 y2. So now we will find distance RC. Okay, I have taken this as x1 y1, C as x2 y2. So using the same above formula, x2 is 4 minus x1 is minus 5 plus y2 is minus 2 minus y1 is minus 1 is equal to 4 minus minus is plus 4 plus 5 is 12 plus minus 2 minus minus plus 12. And 4 plus 5 is 9 is 12 plus minus 12 plus 1 is minus 11 minus 11 12. So 9 9 is 81 plus minus minus the plus 11 11 is 121. So 81 plus 121 is RC is equal to root 202. 202 units. So now we have to check. So how we will check? Using collinearity. So therefore, according to collinearity, collinearity, RB plus BC should be equal to RC. So RB is how much? RB is 5 plus BC was root 85, and RC is how much? RC is root 202. And if we see here, both things are not equal to root 202, so they are not equal to. So it means they don't lie on the same line. So therefore, we will say root, we will say points R, B, and C are not on same weight line. Same thing we will plot and we will have to show him on the graph. Now plot both sets of points and check your answer. So now we have to plot these 3 points and show on the graph that they are not on the straight line. We will draw the graph on the next page. So now we will plot these points. So R is minus 5 minus 1. So first is X and second will be Y. So minus 5 minus 1. So minus 5 minus 1, right? Minus 5 minus 1, minus 5 minus 1. So this is the point. This is R point, which is minus 5 comma minus 1. Then next point is B minus 2 minus 5. So minus 2 minus 5, minus 2 minus 5, 2 minus 5. So this is B point. So B point is minus 2 comma minus 5. And C point is 4 comma minus 12. 4 comma minus 12 is here. Okay. 4 comma minus 12. So C point, which is 4 comma minus 12. So now we will join these 3 points, okay, and we will see if they are on the straight line. So now, so now here you can see that I have joined point R, B, okay, with the straight line, and this blue line is the straight line. And if you can see clearly that the blue line is not passing from point C, okay. So point C is little beside this blue line. So all these 3 points R, B and C are not falling on the same straight line which I have colored in blue color, and C point is little beside the straight line. So C point is not on the straight line, and C point is little deviating. It is not on the straight line. It is little beside the straight blue line, and I have shown it with the red line. So C point is not falling on the same straight line. So that is how we have plot all the points, and we have checked the answer. So all the 3 points, they are not on the same straight line. So this completes our question number 7. Now we will see question number 8 on the next page. So now here we will be seeing question number 8. Using the origin as one vertex, plot the vertices of a right angled isosceles triangle. So vertex means the corner point. So we have to take one vertex as the origin, is what they have told in the question, and plot a right angled isosceles triangle. So any coordinates we can take. What I will do is I will take here 3, and here also I will take as 3. Okay. So let me name this as A, and x is 0, y is 3, and let me name this as point B, and B point is x is 3 and y is 0, and it is right angled here at the vertex. It is becoming right angle here at the vertex where x and y axis are intersecting. Now we will join these 2 points, and we will get a right angled isosceles triangle. Okay, I will join these 2 points now. So here I have joined point A and B. So now this is becoming a right angled isosceles triangle. So here if we see angle AOB, okay, angle AOB is 90 degree, and here these two sides are equal. This side is equal with this side. So here OA is equal to OB, and this point is O, so which is equal to 3 units. Both are equal. So therefore the right angled isosceles triangle is triangle AOB, because it is becoming right angle here, and it is isosceles. Two sides are equal. This side is not same, but these two sides are same. So triangle AOB is a isosceles triangle. So this completes our eighth first sub question. Now we will see second sub question on the next page. Now here we will see eighth the second sub question, an isosceles triangle with one vertex in quadrant 3 and the other in quadrant 4. So this is third quadrant, and this is fourth quadrant. So one vertex is corner point should be here, and one corner point should be here. So and the origin should be one vertex. So we have to take this as one of the vertex, and it has to be isosceles. One point in quadrant 3 and one point in quadrant 4. So I will take one point here and one point here. Okay, and I will name this as O. I will name this as B. I will name this as C. And the B coordinates are minus 3 minus 4. So minus 3 comma minus 4. And C coordinates are 3 comma minus 4. 3 comma minus 4. And O is 0 0. O, okay. Now what I will do is I will join all these 3 points. Okay, and it will become an isosceles triangle. So now here if you see, this side is equal to this side. So it becomes isosceles triangle. So these two sides are equal and this side is different. So here we will write here OB is equal to OC. Therefore, the isosceles triangle is triangle OBC. Okay. So this completes our second sub question of 8. Guys, subscribe my YouTube channel. Thank you very much.